Okay, so for this video, we're going to be doing two proofs. They're both trigonometric proofs, and basically one is going to involve a common denominator, and the other one's going to involve using a conjugate to prove it. So whenever we're dealing with this type of problem, we want to say, okay, well, what's the simplest side to deal with in this case? Or what's the one we want to try and work with so that we can get it into the simpler form? In this case, I would say, okay, well, this one's already seems to be in a final form. I don't really want to expand that one, although we could. I think it makes more sense to deal with this one and see what we can do here. So for our next line, what we're going to do is we're actually going to create a common denominator. So that's going to include multiplying this denominator up to the top here, and then multiplying this denominator up to here, both top and bottom, obviously, and that's going to create our common denominator with our new terms. So if we multiply the 1 minus sign up to this route, top and bottom, that's going to give us 1 minus sine x plus, what's this one multiplied up to here? Well, that's just 1 plus sine x. Okay, perfect. And then that's all over the common denominator of the 1 plus sine x in bracket times the 1 minus sine x. Okay, so now where do we go from here? Well, I guess my first point of action would be, let's try and combine some of these terms here. So we know that we have a plus minus sign, so the negative sine x and the sine x will cancel, so we got rid of those. Then we have 1 plus 1, so we know our numerator is just 2, and we'll keep that denominator for now, 1 plus sine x bracket 1 minus sine x. Okay, and then let's make sure to keep our equal sign. Now what's our next step? Well, we want to FOIL out these brackets or expand the brackets and see what we get. So we're going to get 2 over, well, 1 times 1 is just 1. 1 times negative sine is negative sine x. Sine x times 1 is just plus sine x. Sine x times a negative sine x is just negative sine x squared. Okay, so now what do we do? Well, we see we have a plus minus sign, so those technically can just cancel out now. And then our final line is actually just 2 over 1 minus sine squared x. And the equivalent of 1 minus sine x squared is actually just cos squared x. And 1 over cos x squared, I guess I'll show that off to the side here. So now we have 2 over cos squared x, because that's the identity for 1 minus sine squared x. And then what's 1 over cos x in general? Well, that's just secant. So in this case, we can actually say, if we have a 1 over cos squared x, that's just actually equal to 2 secant squared x. And thus we've proved our first proof. Okay, and now we're going to use the conjugate base. So last one we used a common denominator, and this one we have to use a conjugate to solve. Technically, we could solve on either side in this case. We could either deal with the left or the right, but for the sake of this problem, I'm going to show you using a conjugate on the right here. So a conjugate is where we're going to multiply the same thing that's in the denominator, top and bottom, with opposite sign in the middle. So we're just going to do that quickly, which will give us our 1 plus sine x on both top and bottom. What's our next line going to be? Well, let's say we're going to have cos x, and it's multiplied by both the 1 and the sine x. So I'm going to keep those in brackets, over 1 sine x in brackets and 1 plus sine x. Okay, well, this should look familiar because we actually expanded that one out in the last problem. I'm going to keep that numerator together like that, not foiled out, because I want to keep it so that possibly we can make a cancellation here. So when we expanded our denominator, and when we expanded in the last problem, we got 1 minus sine x plus sine x, and then minus sine squared x. And remember from last problem, we said, okay, well, the sine x is canceled in the middle. So then we were just left with, let's rewrite our numerator, cos x, 1 plus sine x, and then 1 minus sine squared x. And we know that 1 minus sine squared x is actually just equal to cos squared x. So we can sub that in as cos, let's rewrite the numerator one more time, sine x over cos squared x. Okay, and then now what do we notice? Well, we have a cos in the numerator and the denominator, so we can actually just cancel this one, cancel one of the ones in the denominator, and then we are left with 1 plus sine x over cos x. And you see we have the same terms on both the left and the right, therefore we've proved our problem.